All right, Algebra 2. We're halfway done with this unit, and so we're going to go ahead and start Unit 2.3. And so we're going to look at simplifying rational expressions, multiplying, and dividing also. So rational numbers are any number that can be turned into a fraction, a over b. A and b have to be integers, so 1, 2, 3, or negative 1, negative 2, negative 3. A can be 0, but b cannot be 0. And that's, again, you can't divide by 0. If you remember from slope from Unit 1, you can't divide by 0. All right, and so rationals, same thing. You can't write a number where the denominator is 0. The numerator could be 0, but the denominator can't. So any number that can be turned into a fraction is called a rational number. Irrational numbers are numbers that can't be turned into rational numbers. Or if you were to look at its decimal, it goes on forever, and there's no pattern to it, though. All right, so we're going to look at some of these numbers here and determine if they're rational or not, and we can kind of discuss what makes them rational and not. All right, so number 1 is 3/4. 3/4 is already written as a fraction. 3 and 4 are both integers, so that means 3/4 is a rational number. Number 2, 3.14. Well, it's a decimal and it stops. And if you remember, 3.14 is 3 and 14 hundredths. That's the same as 4. The 4 is in the hundredths position, so that's 3 and 14 100ths. And since that is a fraction, that means 3.14 is also a rational number. And number 3, 5 divided by 0. Since it is a fraction, but since 0 is in the denominator, it's not rational. Number 4, square root of 5. Well, square root of 5 you could turn into a fraction. You know, you can just put it over 1. But because square root of 5 is not an integer, that means that the square root of 5 over 1 is not a rational number. And if you put square root of 5 in the calculator, you can see it. It's a decimal, and it goes on forever. And there's no pattern to it. So as long as there's no pattern, then it's going to be an irrational number. If there's a pattern to it, like 0.333333, then it's a rational number. All right, so number 4, square root of 5 is not rational. It's irrational. Number 5, 23. 23, you could write it as a fraction, 23 over 1. 23 and 1 are both integers, and so 23 is a rational number. Just like 6, negative 1, you could write it as a fraction, negative 1 over 1. Negative 1 and 1 are both integers, and so that is a rational number also. Number 7, 0, you can write 0 over 1, that's okay. 0 and 1 are both integers, and the 0 is on top, so that makes it okay. So that means 0 is also rational. Number 8, pi, the symbol pi. If you put pi in the calculator, it's going to be 3.14, and it's just going to go on forever on your calculator, and it doesn't ever repeat and never stops. So that means pi is not rational. It's an irrational number. Number 9, square root of 16. Well, square root of 16, like the square root of 5, is different. They're both radicals, but square root of 16 does simplify. Square root of 16, if you put it in the calculator, it comes out to be exactly 4, and it's not a decimal. All right, so since 4 is a rational number, because you could write it as 4 over 1, that means that square root of 16 is also a rational number. All right. All right, so we're going to look at excluded values. Sometimes they're called extraneous solutions or restricted values. All they are numbers in a fraction, a rational number, that make the denominator 0. So numbers that make the denominator 0, we don't want that. All right, and so typically we do that before we start trying to cancel things out. All right, so number 1, 2, and 3, here we're going to state any excluded values on the variables. So all we have to do is look at the denominator and find out what number or numbers make the denominator 0. So here we have the denominator. It's already factored for us, and if it's not factored, you do want to factor, and you don't have to deal with the bottom, the denominator, when they're talking about excluded values. So since the denominator number 1 is already factored for us, if we set x minus 2 equal to 0 and solve it, and we set x plus 3 equal to 0 and solve it, we can get our excluded values. And so here, the excluded values would be 2, and then the other one would be negative 3. All right, and so let me show you why. If I put 2 cross this one out. If I put 2 right there for x, and I put 2 right here for x, what's going to happen is I'm going to get 2 minus 2, which is 0, for the first parenthesis, 0. The second one, I'm going to get 2 plus 3, which is 5. And then I multiply 0 times 5, I'm going to get 0. And I can't divide by 0. So 2 makes it 0 in the denominator. Likewise, if I take negative 3 and I plug them both in for x's on the bottom, I'm going to get negative 5 for the first one, but then I'm going to get 0. Negative 3 plus 3 is 0. Negative 5 times 0 is going to again turn to 0. All right, so 2 and negative 3 are the two numbers that make the denominator 0. Those are the excluded values. All right, number 2. Again, it's already factored for us on the bottom. So here, because there's an x next to the 4, we're going to set that equal to 0. And then x plus 5 has a variable, and we're going to set that equal to 0. And we solve it. All right, so the first one, if I divide it by 4, I'm going to get 0. 0 divided by 4 is 0. Second one, I'm going to subtract 5 over. I'm going to get negative 5. So this has two excluded values, again, 0 and negative 5. All right, number 3, all right, so I have this fraction, negative 4x minus y over 2x plus 5. Well, the 2x is in the denominator. This 5 has, you can turn it into a fraction, you can put it over 1, but since there's no variable, you don't have to worry about the 1. You only deal with the variables. So the only variable in the denominator is the 2x part. So if I set 2x equal to 0 and solve it, I'm going to get 0. All right, 0 divided by 2 is 0. So 0 is the only excluded value. This one only has 1. All right, so sometimes you're going to get 1 excluded value, sometimes 2, you can get 3 or 4. All right, so it all depends how many x's are in the denominator when you factor. All right, so now what we're going to do is for each of these, we're going to state the excluded values, and we're going to go ahead and start simplifying. And that's just like cross-canceling or canceling, just simplifying a fraction. Okay. All right, so the first step is make sure you factor everything. You're going to factor your numerators, factor your denominators as far as you can. So go back and look at all your factoring that we did in Unit 1, all the different techniques in factoring, because a lot of those are going to come back again. All right, so x minus 2, that's not going to factor. All right, so just there's x minus 2. Now I'm going to put it in parentheses just because it's easier to see when you start to cancel things out. Now x squared minus 4 is a difference of squares. Well, this is going to factor into x plus 2, x minus 2. All right, so I try to keep all my binomials, the two terms, in parentheses, so you can see the like ones, and the like ones are the ones that you can cancel. So I'm going to state my excluded values first. All right, so x plus 2, again, if I set that equal to 0, and then x minus 2, set that equal to 0 and solve it, I'm going to get negative 2 and positive 2. It doesn't matter the order, we just got to list out the correct ones. So negative 2 and positive 2. Now when I simplify my fraction, I'm looking for the same thing on top and bottom. Well, I have an x minus 2 on top and an x minus 2 on the bottom. I can cancel those out because they're the same. All right, now everything canceled out of the top, and so when that happens, you have to make sure you leave something on top. So I'm going to leave a 1 up there. All right, so this will simplify down to 1 over, and I'm going to just leave this in parentheses, x plus 2. 1 over x plus 2. All right, number 2. Let's see, the top, the numerator, I can't factor any further. The bottom, the denominator, I can't factor that any further. So everything's factored. Now I want to state my excluded values before I start to cancel anything out. All right, so this 2x, set that equal to 0. Set x minus 5 equal to 0 and solve it. My excluded values are going to be 0 and 5. All right, so now I want to go ahead and start canceling. All right, I have an x plus 5 binomial on top and an x minus 5 binomial on the bottom. Since they're not exactly the same, one's a plus, one's a minus, I can't touch them, I can't cancel them out. They have to be exactly the same, okay? And if they're not exactly, you can't cancel them out. All right, now the negative 4 over 2, since those are just coefficients, I can simplify that. Okay, negative 4 over 2, I can divide by 2, that's going to be negative 2 over, I can put the 1 there, that's fine. X cubed, x to the third over x, if you remember, with exponents, you subtract exponents. So I'm going to take that x away and make that 3 a 2, because I'm subtracting one of the exponents. So I have a negative 2 coefficient, x squared, x plus 5 over x minus 5. And so that's the way I'm going to write it. So I have a negative 2 x squared, x plus 5, all over x minus 5. Now you don't have to put the 1 in front, but you can, but you don't have to. All right, number 3. Looks like there's factoring that's going to happen on this one. All right, so trinomial on top. So remember, trinomial, use the x method. Let's do it right here. So 2 goes on top, negative 3 goes on the bottom. So what's that? Negative 2, negative 1. So it's x minus 2, x minus 1 over. Let's see, this denominator can pull a GCF out, a 2. I'm left with x squared minus 1. But then x squared minus 1 is a difference of squares, so that's x plus 1, and x minus 1. So I'm going to write all that down here at the bottom. So I can see everything's been factored. 2 times x plus 1, x minus 1. Now I'm going to state my excluded values. So x plus 1, I'm going to set equal to 0 and solve it. X minus 1, same thing, and then solve it. So I'm going to get negative 1 and positive 1. All right, now the 2 in front, I don't have to worry about it because there's no x with it. So those are my excluded values. Now I'm going to simplify this. So remember, you can only cancel something on top with something on the bottom if they're exactly the same binomials. Okay, that's the way binomials work. With monomials or single terms like coefficients, like we did on number 2 in front, those don't have to be exactly the same. All right, so let's see. I have an x minus 1 on top and an x minus 1 on the bottom. I can cancel those out, and that's going to be it. All right, so I have an x minus 2 on top. On the bottom, I have a 2 in front with an x plus 1. All right, don't cancel the 2 on top with the 2 on the bottom because that 2 on top belongs to the binomial x minus 2. Okay, and that 2 on the bottom is just it's called a monomial term, a single term, and you can't cancel a monomial term with a binomial. Okay, so that x minus 2 would only cancel if there's another x minus 2 on the bottom. All right, so let's keep going. All right, number 4. So we have a trinomial on top, so we're going to use the x method for factoring. So negative 14's on top and 5's on the bottom. And so it's at 7 and negative 2. So I'm going to put it right here. So x plus 7, x minus 2. On the bottom, I'm going to pull a GCF out, which is 3. Pull 3 out. I'm left with x squared minus 4. But then that's a difference of squares. So that's 3 times x plus 2, x minus 2. All right, now that's all factored all the way. Now we'll go ahead and state the excluded values. So we'll set x plus 2 on the bottom equal to 0. We're going to get negative 2. We'll set x minus 2 equal to 0, and so we'll get x equals positive 2. All right, now we'll go ahead and cancel like terms out. So I have an x minus 2 and an x minus 2 can cancel. And that looks like it. So on top, x plus 7. On the bottom, 3 times x plus 2. Okay, x plus 7 over 3 times x plus 2. All right, number 5, we're going to go ahead and factor the trinomial. All right, so on top, we multiply 2 and 3 together. We get 6 on top, 7 on the bottom. So that's going to be 6 and 1. But because we're leading off with a 2, we're going to go ahead and divide those by 2. We'll simplify the ones that we can simplify. 6 over 2 is the same as just 3. 1/2 doesn't simplify. All right, so this will factor into x plus 3. And if you remember, the bottom's up 1/2, the 2 comes up next to the x, and then plus 1. All right, and then the other one, x squared plus 7x plus 12. Let's see, let me put it over here because I'm going to run out of room. So 12's on top, 7's on the bottom. It's going to be 4 and 3. So x plus 4, x plus 3. So that's factored all the way. Now we'll state the excluded values. Again, they only come from the denominator. So we'll set x plus 4 equal to 0. And if we solve that, that's negative 4. And if we set x plus 3 equal to 0 and solve it, we're going to get negative 3. So I can cancel an x plus 3 with the x plus 3, and that's going to be it. So 2x plus 1 binomial on top, x plus 4 binomial, binomial on the bottom. All right, 6. Let's see, we have a trinomials. Use our x, 36 on top, 20 on the bottom. It's at 18 and 2. So that's going to be x plus 18, x plus 2. On the bottom, I have to pull, let's see, a GCF out. They both have x's, so I'm going to pull that x out. And let's see, again, I'm going to run out of room here, so erase that. So I'm going to pull the x out, and I'm left with x squared minus 4, but then that's a difference of squares. So that becomes x plus 2x minus 2. And don't forget that x in front. All right, excluded values. I have the x in front. If I set that equal to 0, I'm going to get 0. The x plus 2, I'm going to get negative 2. The x minus 2, I'm going to get positive 2. Now I'm looking for the same binomials to cancel out. I have an x plus 2 and an x plus 2. And that looks like it. So x plus 18 on top. On the bottom, x times x minus 2. All right, so that's simplifying fractions. Multiplying and dividing. So we're going to use the same concept of multiplication division from elementary school. So remember, when multiplying, you multiply straight across, and with dividing, you change to multiplication and flip the right side fraction, and then you just multiply across. All right, so with multiplication, we want to go ahead and factor first, just like we did with simplifying. And so x squared minus 4 on the bottom, that's a difference in squares. So that's going to factor into x plus 2x minus 2. All right, and then I can go ahead and simplify. So x minus 2 binomial can cancel diagonally. So you can cancel diagonally or top and bottom. The 4 and the 16 will simplify. Cross those out. So on top, if I multiply across, I have 4 on top. On the bottom, looks like just x plus 2. Okay, again, you can't cancel the 4 and the 2 out because the 2 belongs to the binomial x plus 2. Division, again, we'll change to multiplication, and we flip the right side fraction. Right, so the left fraction stays exactly the same, and the right side we flip. Right. And then we would try to cross cancel diagonally top and bottom. I have an x plus 3 and an x minus 3. They're not exactly the same, so I can't cancel those out. Let's see, the 6 and the 9, I can divide by 3, so that turns to a 2. 9 changes to a 3. I can cancel this x with one of these x's out. And so that looks like it. So I have a 3. I'm going to keep all these in parentheses. Okay, on the bottom I have a 2x, and then x minus 3. Okay. So it helps put in parentheses. The order doesn't matter as long as you have everything on top correct and on the bottom. All right, so now let's go ahead and we're going to multiply and divide, and we're going to state the excluded values. All right, so remember when we do excluded values, we want to find them before we start canceling things out. You want to factor everything, but you want to get them before you start canceling. So excluded values. So on the denominator, I have an 8x and an x plus 3. So if I set 8x equal to 0 and solve it, I'm going to get 0. And if I set x plus 3 equal to 0, I'm going to get negative 3. So when I cross cancel, the x plus 3 binomial can cancel with the x plus 3. I can divide 8 and 12. 8 can be divided by 4, turns it into a 2. 12 can be divided by 4, that turns to a 3. The x on the bottom can cancel with the x squared, one of them. And that looks like it. So on top, so be careful with your canceling that you don't cancel too much. 3x, x minus 3. And then on the bottom, looks like 2. All right, number 2. I can factor, pull a GCF out, pull a 4 out. X squared minus 16, I can factor. That's a difference of squares, x plus 4, x minus 4. All right, everything's factored. And so now I'm going to state my excluded values. So the first one, x minus 4 from the 4 times x minus 4. Excluded value would be positive 4. And then I have a 4x in the denominator. That would be 0. All right, now I want to look at canceling like terms out. So x minus 4 and x minus 4, those are the same. Let's see, the 4 and the 6, I could divide by 2 here, top and bottom. I can cancel this x with this x here, and that looks like it. So then I'm just going to multiply what's left. So on top I have a 3 and an x plus 4. Keep the x plus 4 in parentheses. And on the bottom I have a 2 and a 4, and I can multiply those together. That's 8. All right, number 3. So division works the same. Again, we're going to change the multiplication, and we're going to flip the fraction on the right side and factor everything. So x minus 2 squared means x minus 2 times x minus 2. So I'm going to go ahead and write it twice over 3x. All right, the division changes to a multiplication, and then I'm going to flip this. 12x to the third is going to go to the top. All right, the x squared minus 4 is going to go to the bottom, and I can factor it. I'll go ahead and factor it right now, x plus 2x minus 2. All right, so now I want to state my excluded values. So this is where it could be a little tricky with division. Excluded values come from all denominators, from after we flip it and before we flip it. Okay, so before we flipped it and after we flip it. So the 3x here has an excluded value of 0. X plus 2 has an excluded value of negative 2. X minus 2 has an excluded value of positive 2. And then this 12x to the third was in the denominator in the original problem, and it has an excluded value of also 0. And since I already have it, I don't need to write it again. All right, so now I want to go ahead and cancel things out. So I have an x minus 2 diagonal with an x minus 2. I have a 3 in the 12. The 12 will turn to a 4. And then the x with the x cubed turns it into a 2x squared. All right, so then that looks like it. Now I just have to clean this up a little bit. So I have 4x squared. I'll write that first. And then the binomial x minus 2. On the bottom, looks like the only thing on the bottom is x plus 2. And again, don't cancel x minus 2 with x plus 2 because they're not exactly the same. All right, and then let's see, last two problems, division. All right, so again, the first fraction, 6x, and then I'm going to factor 4x minus 16. I can pull a GCF out, x minus 4. Turn to multiplication. This fraction flips. 4x on top comes to the bottom. X squared minus 16, that's a difference of squares, so that's going to factor x plus 4x minus 4. All right, let's think the excluded values. So x minus 4, since it's in the denominator, if I set it equal to 0, I'm going to get 4. 4x is in the denominator. Set that equal to 0, I'm going to get 0. Now, x plus 4 and x minus 4, they were in the denominator in the original problem from the x squared minus 16, so I have to set each of those equal to 0 and solve it. So I'm going to get negative 4 for the x plus 4, and then I'm going to get positive 4 for the x minus 4. But I already have positive 4, so I don't need to list it again. All right, so now I want to go ahead and cancel x minus 4 with x minus 4. Let's see, I can cancel the x with the x. I can divide by 2. All right, so I get 3 x plus 4 on top. On the bottom, this 2 and the 4, multiply those together, I get 8. It's very similar to the other problem that we did before. All right, and then number 5, last one. I'm going to factor x squared minus 25 first. That's x plus 5, x minus 5, x minus 3 on the bottom. Turn to multiplication. I'm going to flip this fraction, so x plus 5 on top goes to the bottom, x plus 5. X squared minus x minus 6 goes to the top, but since it's a trinomial, I'm going to have to factor it, so I use the x. So negative 6 and negative 1. So that's going to be negative 3 and positive 2. So x minus 3, x plus 2. All right, so now I excluded values. From x minus 3, I'm going to get positive 3. From x plus 5, I'm going to get negative 5. X minus 3x plus 2, since they originally were in the denominator from the x squared minus x minus 6, I have to set those equal to 0 also. And so I'm going to get positive 3 for x minus 3, but I already have it. And then negative 2 from the x plus 2. All right, so those are my excluded values. I just want to cancel like terms out. So x plus 5 can cancel with x plus 5. X minus 3 can cancel with x minus 3. And that's it. So what's left is x minus 5 times x plus 2 all over everything canceled on the bottom, so it's really over 1, so you don't have to write it. Don't multiply this stuff back out, don't distribute or anything, just leave it in factored form. All right, and that should be it. All right, so go ahead and try the homework now.